was saying a minute ago before a lot of you got here, this is going to be probably a shorter presentation, hopefully not take up the full 45 minutes, and we can have some discussion, certainly some Q&A if you guys are into that. I'm pretty informal, so I'm probably just going to sit on this table here and kind of talk a little bit. Before I get started, does anybody here have any sort of background in permaculture, ecological restoration, design, any kind of hands-on stuff? I know Craig does with some wilderness survival and that kind of thing. Okay, just, it's good to know who I'm talking to, and certainly if you guys do have questions or anything that I say really makes no sense or just goes over your head or I use a word you don't understand, go ahead and interrupt me. I'm totally cool with that. And let's see here. So the title of the talk is Food Sovereignty Through Water Cycle Restoration. Big words, kind of two separate topics, food sovereignty and water cycle restoration. I'm going to start with water cycle restoration and what that means. So this is a graphic that I like to use in every opportunity that I get. And basically what you have is, here on the top is a physiographic representation of Kentucky as we think it might have existed prior to Western settlement and colonization. And then on the bottom, sort of what it looks like now. And I know it's a little small, but the two things I'm going to point out here is that in the modern map, you see all these red points. That's urban areas, so Louisville, Covington, here in Lexington, and so forth. And what really defines that red is impervious surface area, so pavement, asphalt, roofs, basically anywhere that rain's going to fall and it's not going to be able to go into the soil like it would in a natural vegetated system, right? And then looking at what we had prior to colonization and Western settlement, you see all this yellow throughout. And just note that there is pretty much no yellow in the modern. The yellow are wetlands. So that is a very distinct kind of ecology. It has to do with the water retention in the soil, the hydric soils that would stay wet for a certain period of the year. And there's a lot of ecological function tied into those wetlands. So the filtering of the water, the kind of the microclimates that are created with all of the water vapor that's moving through the systems, the water moving through the soils, obviously, and all the habitat. I mean, just think of all the beavers that would have been active through here and sort of the engineering, the natural engineering that those species would have been doing on the landscape that we have basically lost. You can see we have just totally extirpated the wetlands from the state. We have a little bit still going on in the Mississippi embayment area in western Kentucky, as you would expect. But we have really changed how the landscape is functioning. And this is something that is played out on a continental scale and even internationally. Because if you think about conventional agriculture, one of the first things that they do is put in drain tile or figure out how to get it so that these fields are not flooded or there's not a lot of standing water in the spring or in the planting season, because a lot of your annual crops, wheat, soy, corn, whatever, they are not wetland adapted species, so they're not going to hang out in that kind of moisture.
What is the gray?
The gray is a prairie. So, and we have more prairie or kind of shrub cover now, but you shouldn't confuse that with the western tallgrass or shortgrass prairie and kind of the really deep soils that exist there and that have taken millennia to build up. This is really just means basically we've cut down the majority of the trees that would have been there. And that's an interesting point too, because there is kind of a cultural mythology in this part of Kentucky that it was always this open, rolling bluegrass landscape. It didn't look that different from the horse farms we have now. There were these venerable oak trees that kind of stood sentinel here and there, and the bison would graze through, and the native peoples were managing the landscape with fire and keeping it open. And that's true in certain extents in different ways in different parts of time, but to be sure, the area that we're in right now traditionally would have been a forest or a woodland at least. It certainly would not have looked anything like the horse farms. Yeah.
Isn't there a portion of Kentucky that really is tall grass prairie, like maybe 10 or 15%?
Yes, and that is a really important part of the native ecology of the state, and something that needs to be considered in restoration and often isn't, especially when people say, oh, we need to go plant trees and all this. Another thing that people really forget about is giant cane. When Western peoples first came into this area, they crossed the mountains. They kind of called this the fabled cane lands. That was kind of some of the things that people like Daniel Boone would use to describe this area. And so the native giant cane, which is like a massive bamboo that will actually, even if you're on a horse, sometimes you can't look over it. That is a really particular kind of habitat. It's super dense, and that has also been removed. Kentucky bluegrass, what we think of as bluegrass, is not native to Kentucky. It's sort of an erosion control creation during the Dust Bowl era, and it's for soil stabilization. But a lot of what we think of as bluegrass ecology actually doesn't have anything to do with what this area would have been historically. So let's talk about the water cycle just a little bit. Here's a graphic that shows the quote-unquote natural water cycle. And just like we learned in school, it's going in a circle. This is very simplified. It's not just one circle, right? There's many different iterations of this cycle that happen throughout the landscape on different scales. But the general idea being water evaporates from large bodies of water, from any kind of standing water, goes into the atmosphere, condenses up there, and falls as rain. And it just kind of keeps going like this. But as it infiltrates into the soil, you have all of this activity in the groundwater, and this feeds the microbiome of the soil. It feeds the ability of the landscape to sustain large trees and other vegetation that are kind of using that water. Really can't overstate the importance of water, right? Like when NASA goes into space and they're looking for where's life on other planets, what's the first thing they're looking for indications? It's water, right? So when we think about water, we're thinking about our landscape's ability to actually sustain life. And not just ourselves, but also the kind of trees that potentially we as environmental advocates are saying we should be planting more trees, we should be planting more trees. We need the water cycle to actually make that work. And we'll talk in a little more detail about all that. But the urban water cycle, or what we've mostly shifted to on a large scale, certainly in dense urban cores like in Lexington, like in Louisville, etc., we have basically cut off that infiltration because of the large amount of impervious surface area, parking lots, and so forth. And so we lose the groundwater flow. We lose that ability to sustain the natural microbiology of the soils. We pick up a lot of pollutants from our roadways, etc., and that volume that did not go into the soil, did not get filtered, isn't getting processed biologically, is just ending up directly into whatever drainage, whatever watershed you happen to be in, your creeks to your rivers, into your larger bodies of water. And you see a lot of issues with that, like the dead zones that we get in the Gulf. That's as a result of nutrient loads from agricultural fertilizers and things like that. Basically, we could talk on and on and on about how impacted this is, but when we're talking about water cycle restoration as a concept, these are the two ideas. This is kind of where we're at now versus naturally what we should be kind of having on a landscape scale. So just a little more detail about that. Something else that we have, and this has been a cultural facet for decades, if not 100 years. It's only just now starting to change, but coming from that agricultural thing of drain the water away. The water is bad, it brings mosquitoes, disease, we can't plant into it, it's going to hurt the foundation of your building, whatever, so just get it off, make it the neighbor's problem, then the neighbor has more volume, and they make it their neighbor's problem, and on and on and on. So the water falls here, and we have these direct pipes connecting to wherever it's going to dump out. You see these stormwater head walls along creeks all over the place in urban areas, where basically the water is just running from somewhere further upslope, and it's running along a smooth pipe, so it only ever gathers volume from all these storm sewers intakes. It only ever gathers speed, because it's going down slope and doesn't have anything slowing it down. It's just a straight connection, which is not what it would be doing in nature. In nature, it would be meandering, right? And so all that volume, again, all the pollution that it picks up, and quantity is kind of a pollutant all of its own, because that's where you get your soil erosion, all these other kind of things that are going to choke out the natural systems. So this graphic kind of shows, okay, on top, what you might expect from a natural system. You have a meandering kind of stream morphology that is able to adapt. When you have a large storm event or a flood or something like that, it's going to change, but it kind of has the ability to grow. It has a sort of dynamic natural system to it, and then we, in kind of our worst sort of colonial, I'm going to freeze this in place and it's going to be like this forever, and we're the humans and we know what's best. We come in and straighten this, and then it loses the ability to adapt and to respond dynamically to whatever natural inputs are happening, and that's where you get floods in urban areas and all kinds of other issues. And when we do this, maybe on a limited time frame, even a human life or a few decades, this works out okay. But especially when we're talking about geologic time, but even when we're just talking about what we're going through now with all the different changes to the climate, the intensification of rainfall patterns and so forth, pretty much all the infrastructure that we've built over the last several decades of urbanization is just no good. It's not serving ecologically, but it's also just not going to stand up structurally to basically the challenges of the years ahead. And the American Society of Civil Engineering has rated, I think most recently, American infrastructure as a D+. So, and that's bridges, that's roads, that's all kinds of things, but it's certainly all of our stormwater infrastructure. Just generally speaking, we're not set up to accommodate what's coming, what's already here.
Doesn't Lexington have a big stormwater issue that they've been trying to correct for, I don't know how long?
Yes. So about a little over a decade ago, the EPA sued the city for violations to the Clean Water Act that were mostly related to E. coli and kind of some other contaminants because of an aging sanitary sewer system, and some of those overflows were ending up into our creeks and so forth. And so that's where, if you were paying utilities at the time or are now, you'll notice that there's a stormwater management fee that kind of gets tacked onto your sewer bill. That's part of that. And so there's been a lot of work done over the last decade for retrofitting sanitary sewers, making sure that they're not leaking anymore. And then there's also a lot of issues with storm sewers, which is a separate system, but sometimes if one overflows into the other, or if the storm sewer is not designed correctly to handle a certain volume, then it can kind of overflow as well and create flooding. We've had a number of properties, we'll talk about this a little later, but a number of residential properties in Lexington that have been bought by the city and demolished because they were built in floodplains, precisely where we shouldn't be building, right? So we can have room for those dynamic systems. And so that has been a major narrative for a while now, especially for people in my line of work. When we go after grant funding and stuff like that, typically some of the most available money is if you attack it from a water quality perspective and say, how are we going to reduce either the volume of water that's getting dumped into the creeks or improve the quality of what's going in there. And we could talk forever about all the different classes of pollutants and how they act in aquatic systems and impact those things. But a lot of it sometimes is not measured in a way that I think would benefit us from a more holistic ecological kind of perspective. Some of that is still stuck in a, the EPA has it legislated this way, so it's like these particular contaminants of concern, and these are the only things we're looking at, and we kind of have to find ways to deal with some of the other stuff, just kind of, well, we have to be strategic about what we do with the money. But that is some of what we're talking about, hopefully. So this is tiny, I'm sorry. I wish this was a little larger, but I'm not going to ask you to read all this, but this is just an academic paper that I really like, and it's stream restoration in urban catchments through redesigning stormwater systems. And just a couple of the main points here that I want to talk about. First, restoration of streams degraded by urbanization has usually been attempted by enhancement of in-stream habitat or riparian areas, which is the zone directly adjacent to the stream. What they are saying is that such restoration approaches are unlikely to substantially improve in-stream ecological condition because they do not match the scale of the impact, the urbanization that's happening, not just along the riparian zones, but everywhere upslope of that, that impacted water cycle. So the next point here, the direct connection of impervious surface areas, what we were talking about, where it goes into a storm sewer here, it runs underground, it has no opportunity to infiltrate into the soil, and it dumps into the creek. That's really the biggest problem that we're dealing with. And then as a conclusion, distributed low-impact design measures that are required to intercept rainfall from small events and get them into the soil. And so even though sometimes it's easiest to get the funding and people want to see trees planted along the creek, it's actually all the upslope areas on a landscape scale that we need to be doing all these tiny little things, rain gardens in your front yard, taking out parking lots and malls and putting in retention basins there, all these different things. Bringing wetlands back, actually, bringing that natural ecology back into what we understand and think of as a city. So basically redesigning how an urban area functions hydrologically is what it's going to take. So the other thing that I want to talk about is climate mitigation. Oftentimes when we talk about climate change, climate impacts, people really focus on carbon and greenhouse gases and this kind of thing. That's certainly important, but it's a little bit of a red herring. And the reason for that being, the thermal regulation of the Earth's biosphere is much more connected to the hydrologic cycle than it is to the carbon cycle. By a factor of, by maybe an order of magnitude, really. And this is kind of an artifact of 1970s climate science, when in the Mauna Loa Observatory they saw, oh, carbon was going up, let's look at that, let's see what else is going on. And it just so happens that we can measure carbon much more easily, we can track it in terms of its fixation into trees, we can financialize it on that basis and sell carbon credits or whatever, versus think about the water cycle. So just in our daily lives, or just within what we think of as the natural, easily accessible biomes of the Earth, water exists in all three major states of matter, right? Solid as ice, liquid, and we have gas and water vapor. Imagine the energy fluxes that it takes for that water to change, to go through that state change. And it does it regularly, right? Even just in our daily lives, you can watch evaporation and all this kind of thing. So that's an energy flux. That is heat transfer. It's very complex. It's almost impossible for us to model. Certainly in the 1970s, they didn't have the technology to do it, and we still really don't now. So they kind of said, well, it's too complex. Let's just assume that the net effect is zero. Let's just zero it out, and we'll focus on the carbon cycle. So this is something that we need to be paying attention to much more closely. And when you think about it, a tree, through evapotranspiration, is pulling water out of the ground and then taking that heat that's in those water molecules and shooting it back out into space. That infrared radiation is going back out into space through evapotranspiration. And of course, we also have the albedo effect from clouds, and they are reflective. So this is all water cycle stuff. There is nothing that we as humans are ever going to invent that is going to, as efficiently, as cost-effectively, get heat out of the biosphere, right? So we really need to be focusing on the water cycle. And also, here's kind of a trick question. Do trees grow where it rains a lot, or does it rain a lot where there are trees?
The latter.
The latter, yes. So, it's interconnected, right? But the trees are a biotic pump that actually pulls in rain through a variety of methods. But one of the coolest ones that a lot of people don't know about is because of all the bacteria, all of the fungal spores, and all these things that are kind of associated with the stomata on the underside of the leaves, where that gas exchange takes place. They hitch a ride on that gas transfer, on that evapotranspiration, and they become condensation nuclei in the atmosphere. So rain doesn't just form out of nowhere, right? It needs something, those water droplets need to condense to something. There has to be a speck of dust, or a hygroscopic bacteria, or a spore, or something like that, that come from trees, that come from natural vegetation. And so that is how we get rainfall. So we had it backwards. Science had it backwards for a very long time. They say, well, it rains so much here, therefore there are trees. But actually we find, for instance, in places like the Amazon, that the same water is being recycled up to 7 times through that system before it goes back out of the ocean, and that's because the trees are seeding the rain. So as we lose trees, we lose rain. As we lose the water in the soil, we get into these chronically dehydrated landscapes, and that's certainly what we have in Kentucky as a whole, and in our urban areas specifically. And so when we go out and say, plant trees, plant trees, plant trees, they are not going to function in terms of carbon sequestration, in terms of cooling, in terms of any of the things that we say trees are so good for. They're not going to function the way we're saying they will unless we address the water cycle underneath all this stuff. Went backwards. Okay, so just a picture of some of the stuff that we're used to seeing, right? These concrete channels, let's get it off our property. Water is a problem, get it out of here. We have dry detention basins all over town. Once you start looking for this stuff and seeing it, okay, this is kind of a bad picture because it's during a rainstorm, so you can see that it's actually got some water in it, but very little, right? And most of the time, most of the year, these things are dry. They're just mowed. They're not actually doing anything, right? We call turf grass green concrete or green cement because it has very, very shallow roots. It's not actually infiltrating that water. And this is just kind of to handle the peak flows from something like the adjacent parking lots and roads, and then it just moves downhill. It does not hang out here in any kind of appreciable way. This is another study. There's just hydrologic and water quality performance of 2 aging and unmaintained dry detention basins receiving highway stormwater runoff. Basically, they just looked at some of these basins. They looked at one that was being mowed, as conventionally done, and they looked at one that was abandoned and no longer received maintenance, and it went to the weeds, and shrubs came in, and yada, yada, yada. What do you think happened? We had improvements in every relevant metric. The quality of the water that was coming out of there as it filtered through, the quantity of the water because it was actually able to be evapotranspired, it was able to get into the soil through the roots, and yet we're told that we need to have these turf basins. This is the only way to manage this. So this is a picture from Seattle, Washington. They have a little bit, they're a little further ahead of us in some ways. But this is an example of what you could see with these curb cuts and where you might have just a turf detention basin. There's no reason why you couldn't have a beautiful garden with all kinds of habitat providing plants. It could be aesthetically beautiful, it could provide green jobs to the community, and certainly it's providing that ecological function that we so badly need. So now I'm going to switch. How am I doing on time? Does anybody know real quick?
It's 25 after 1.
Oh, doing great, all right. So now I'm going to switch to the food sovereignty piece. We talked about the water cycle. Anybody have any questions about the water cycle before I move in and like kind of the foundation of the discussion we're having here? Cool. So, food sovereignty. This is a report from the United Nations Food and Agriculture Organization talking about all the impacts to our food systems globally from climate change. We are currently looking at a lot of these right now. I mean, we see them coming in a way that even moderate people, even conservative people, when it comes to talking about climate change and impacts, are saying we're probably going to have some global famines in the second half of this year. We already see all the reasons why this is happening. It's not just the war in Ukraine. It's kind of like, okay, one straw breaks the camel's back. Let's talk about all the straws that were underneath it. Those count too, right? We've been building towards this for a while. And as we have increasing droughts, as we have increasing variability in local climate, in some cases too much rain or rain at the wrong times, there are a lot of things about the ways that we feed ourselves as a global population of multi-billion people that are not going to stand up to the ecological impacts that are currently unfolding in front of us. So let's talk about that a little bit. Cuba. Cuba is probably the world leader in figuring out how we're going to get through this. And I'll tell you why. When the Soviet Union collapsed, all these different client states that they had basically lost their patron, right? So let's look at North Korea and let's look at Cuba, because they had completely opposite strategies to each other and how they were going to deal with that period, and they had completely opposite outcomes. North Korea went business as usual, they tightened up, and as we all know, famines, massive decrease generationally in the nutrition of their population. I mean, just absolutely terrible authoritarian kind of really abuse of the people in that peninsula, and they have no more resilience than they did when they were just depending on all kinds of imports from the Soviet Union when they were a client state. Cuba, on the other hand, they decided, okay, things have changed. We no longer have tractor fuel that we counted on. We no longer have all these subsidies. We don't have synthetic pesticides that are coming that we can't produce ourselves. We no longer have a market for all the sugar cane that we were growing. So let's not grow sugar cane anymore, let's grow food. Everybody grow food, in fact, they said. They said, do it in urban areas. They decentralized to the greatest extent possible. It's all organic. And no matter how you feel about Cuba, if you have some, political sensitivities about, well, we shouldn't say that they did anything good. I'm telling you that they did. They lead the world now in terms of all kinds of metrics for health, for nutrition, especially their poorest in the urban areas, and it's exactly because they switched to this system. And that kind of impact, they basically went through an economic and food systems collapse. It was, if you want to call it that, a simulated version of climate change or what we are now facing globally. And so they're on an island. So it's like a little experiment that we can look at and say, look at all the things that they did. They did things that didn't work out. They went through a lot of rough stuff, especially in the 90s. But look at the outcomes and look at the resiliency that they have now. They truly are the global leader, and people are recognizing it now and saying, wow, this is something that we should be looking at. And a lot of it is urban agriculture. That's the big thing that I want to hit on, is that they're growing food where people live. People are directly connected to what comes in their plates. They have their hands in the dirt, literally, because it's all organic. It's high nutrient. And so whether or not we like it, this is kind of the future that we're looking at. And I think we have the ability and the responsibility to choose North Korea or Cuba. I kind of know which one I would like to head towards, right? And we have to make that as a conscious decision many thousands of times every day in how we interact with each other, organize our communities, and move forward with the time that we have remaining as these impacts kind of snowball on each other, and we get really more and more challenges to what we've all grown up with thinking as normal. So a couple problems with urban agricultural development. There's always some challenges that people run across. The two that I really want to talk about are urban pressure and high market value of the land. So urban pressure, usually if you have some open land and maybe you get a little farm going, a little urban farm, it's only a matter of time before whoever really owns that wants to put a development there, put a condo there, put whatever the highest, best use of the land is, the most profitable use of the land is. So you don't get the opportunity usually to grow in urban areas for very long, because if you're successful, actually, you end up killing yourself because your successful urban farm makes people want to move to the area. There's a process of green gentrification, and then the next thing, the high market value of the ground. All of a sudden, this land that, in most cases, urban farmers don't own the lots that they're on. They're renting them as nonprofits, or somebody is donating it for a period of time. But at a certain point, the highest, best use of the land per traditional economic metrics ends up being something other than growing food for the surrounding community. So these are the biggest problems that we face usually with growing food in urban areas and high density population centers. So at this point, hopefully you kind of see where I'm going with this, right? We have legacy stormwater systems that need to be retrofitted with more vegetation and more water retention. And then we have the challenge that urban agriculture can strengthen local food systems and security, like what we've seen in Cuba, but finding available land is a challenge. Why don't we put these things together? And we can, in the best kind of permaculture tradition, stack as many functions as possible. Ecologically, we can have a concentration of a lot of positive benefits trying to solve both of these problems and potentially a bunch of other ones as well, particularly social problems like access to food, higher quality, nutrient-dense food, all at the same time. That's kind of the pitch that I'd like to make here. So let's move forward with that idea a little bit. The first thing, okay, conventional agriculture, everything we're used to eating, as we said, doesn't necessarily grow in inundated fields. But we have in the archaeological record and in the extant cultures of indigenous peoples on this continent and all around the world as well, plenty of evidence that there's stuff you can grow in seasonally inundated soils or even in aquatic areas that are perfectly decent crops for human consumption. And so we can go into some of those details if you want, but I just promise you that a lot of the things that you even think of that you may not realize can grow in association with streams are riparian adapted species and can handle wet feet. A lot of them are perennial crops. They are fruits, nuts, things of that nature. So not necessarily the annuals that we're used to thinking of in terms of conventional agriculture. And that's good because switching to perennial crops has a whole host of other benefits that would be a totally different talk, but that is going to be, that's a big focus of the work that I do, is perennial crop production, native perennial plant crop production, and I think that's something that you're going to see more and more of as well in our food systems continentally in the years ahead. This is a diagram from a permaculture design textbook, but just kind of showing a section cut of a landscape where they have put these swales. These are little depressions that are running perpendicular to the slope, and they are intended to catch rainfall as it comes and sink it into the soil. And you get trees that you plant on the downhill berm of these slopes, so they are getting constantly watered through that infiltration. You're capturing that water, it's a resource, you want to keep it on your land as long as possible, cycle it as many times as possible through your land because it's energy. And you also get these microclimates where up here it's probably a little drier, down here it's a little wetter, and it's just, it's a knowledge intense system because you don't plant this whole thing with one monocrop system. You have to know what's going to grow a little better here in the wet, what's going to want a little higher up here, how are they going to play nicely with each other, what are the root systems of each plant. I don't want to put something that's going to compete underground with, you know, something right next to it. We have a tap root next to a fibrous root system, so they kind of, they strategically exploit different strata of the soil. All these kinds of things that you have to take into account that we just don't do in conventional agriculture, but which are definitely possible, and which are the ways that natural systems, natural forests, organize themselves anyway. So this is part of a design that I did where we had, you know, a section where some stormwater runoff was moving through the slope. I said, this is where we want to capture it. We want to put some pools in here, and just an idea of some of the different species that I was thinking about at that time. Some of these I wouldn't use anymore just because they're not native, but they are all good crops. They all provide some kind of habitat function, just to get us thinking about, okay, it doesn't have to be just a detention basin, it's not just a stormwater mitigation kind of infrastructure. It could be food production as well, or medicine, or whatever. To that point, this is a chart showing antioxidant capacity of some different berries. Antioxidants are kind of a broad range of chemicals that they help to prevent free radicals from breaking down, damaging structures in your body, but they're also kind of useful to talk about because they contain vitamin C, beta-carotene. Both these things are antioxidants. A lot of the things that we talk about in terms of like, this is good for human nutrition, fall into this class of antioxidants. So what are some foods that are really high in antioxidants? A lot of people talk about goji berries, pomegranates, as being like, yeah, it's high in antioxidant, drink the juice of that. Look all the way up here, we have aronia, which are the common names chokeberry, and elderberries. Both of these are North American native species. They have the highest antioxidant content. Black aronia is actually being marketed worldwide now as a superfood because of that. They are perennial shrubs, woody shrubs, so you only have to plant them once, potentially. And they both grow with wet feet. They both are adapted to inundated soils. You can pretty much plant them in wetlands, and especially in seasonally wet areas, like a rain garden or something like that. They don't have to be wet all the time, but they can handle it. Their roots can handle that lack of oxygen in the soil, at least temporarily. So look at that cross-section between what will grow in some of these soils and what are some of the most nutrient-dense foods that we can have. I'm not going to make the case here that we're going to get all of our caloric intake from urban agriculture or from these systems specifically necessarily. We could, if we grew a lot of sweet potatoes and popcorn and stuff like that, we'd get the calories. But I do think it's possible and reasonable to say that even on a home production scale, you could get your vitamin needs taken care of on an annual basis. And that's something that we can be shooting for. And definitely if we tie it into stormwater infrastructure on the community scale, we could be providing for our neighborhoods in that way. This, I just added this last night because I'm so excited about this, but this is a sugar hackberry, also called the southern hackberry, Celtis laevigata. The common one that we have around here is Celtis occidentalis, the western hackberry. But this is, I mean, just by the name, sugar hackberry. They taste so good. You can eat these out of hand. And I don't know, they're from a little further south in the United States, but the birds are bringing them north. The climate's coming north anyway. They do well here. They will suck water out of cracked clay. They are so drought tolerant that this is really something that we should be thinking about for long-term landscape sustainability. And the coolest thing is, this is really just a little bit of fruit around a seed, but the seed itself is edible. And native peoples have, for thousands of years, crushed everything together and made like a fruit leather pemmican out of it. You can add animal protein to it, and fat, you can add other berries, you can do all kinds of different stuff. This kind of is like the rebar that holds it all together. And we find in the archaeological record, Celtis, this genus, on every continent as an important part of indigenous food systems. So for me personally, this sugar hackberry is the one that I'm really telling people about now and saying, hey, if you got a tree nursery or whatever, be selling this plant. And I've got 3 different kinds of them in my backyard right now. I'm just trying to get them out on the landscape as much as possible. Real quick, something I want to talk about is contamination in urban soils. Obviously, that is a consideration, it's a concern. Things like elemental lead and mercury, you can't really, especially depending on which molecular form they're in, you can't necessarily remediate with just the microbiome in the soil. But a lot of the things that we do think of as problematic, like hydrocarbons, oils, stuff like that, they do break apart naturally pretty quickly if we feed the soil microbiota, which we can do with wood chips. We can do by adding carbon to the soil, which is what that microbiome feeds off of, that bacteria, the fungi that are going to be doing that work. And then when we do have something like selenium, which can actually take the place of nitrogen in an amino acid and get mobilized into a plant that way, from what we understand, this is something that does need a lot more research, which I would be in favor of, certainly. The way that plants translocate these molecules through their systems is very different in the roots and leaves versus the seeds and fruits. And so if I had contaminated soils and I had to grow food there, I would not grow greens, I would not grow any kind of root crop or anything like that. But if I had to grow something, I would grow fruits. Because from what we know, the fruits are most likely to be, and this depends on the root stock, it depends on the individual species, and so on and so forth. Like I said, we need more research. But if we're talking about urban soils and what we're going to grow there, fruits are probably the most appropriate thing. And just going to wrap up here, but this is an example of something that I've done here in town. This is a stormwater head wall in Wellington Park that was draining where they widened Claysville Road upslope, and it was just dumping water into the floodplain. It was eroding down. We came in with a little bobcat and just dug this series of infiltration basins. We call this a regenerative stormwater conveyance. So the water comes, slows down, pools out, the pollutants can drop out of it, then it continues to the next pool, so on and so forth, spends time there, has time to get into the soil, and so you will see a marked difference in the water quality at the top pool versus the bottom pool, where you have like dragonflies hanging out and all this kind of cool habitat. And then of course, you can't see it in this photo because it was right after we did it. We planted a ton of trees in here, right? Because that evapotranspiration and cooling. This is another project here in town. This is the Kilrush Drive Greenway, where we did have a bunch of residential properties in a floodplain. The city demolished because the basements kept flooding. And now I've been able to get the city to agree to let me clear out the invasive amber honeysuckle and put in dozens of fruit trees. And we've just started doing this over the last couple of years. We've just got the final kind of approval to really do it. But it's going to be a linear acre food forest in collaboration with the surrounding neighborhoods. I believe this is going to be the largest food forest in Kentucky, certainly on public land. I'm really excited about this project. It is right along the creek, so I mentioned we want to be upslope, but if we're doing stuff in riparian areas, here's a great way to do it in an area where they had buildings and they can't anymore, right? That's it. That's the whole presentation. I kind of rushed at the end there because I know we're low on time. Hopefully y'all enjoyed it. If you have questions and stuff, I'd love to talk to you all about this. I really think this is one of the most important strategies that we can be pursuing. Like I said, it's going to address multiple issues all at the same time. This is my social media. I'm on Instagram. Check that out. It's a good way to keep track of what the company's doing. This name, Geomancer Permaculture @gmail.com, is also how to reach me personally. And we do have a Patreon as well if you want to help support in that way. Yeah, thank you.